See here, in last lecture, we started the second topic of the unit first of a paper 12, and that topic is the transistor amplifier. In last lecture, we make the wait, I want to share the screen. मी लेक्चर मध्ये तुला फोन करतो नंतर. Friends, you are able to see the sharing?
Yes, sir.
Very nice, very nice. Okay. See here, this is introduction of the transistor amplifier. In last lecture, we study in detail then what is a transistor, how that semiconductor device is used to transfer the resistance from input circuit to output circuit. That means from base emitter circuit to base collector circuit. What is the process of the amplification? Just amplification is increase or to magnify the AC signal without changing the frequency and the nature of the waveform. We know that in amplification only amplitude is to be increased. There will be no change make in waveform as well as the frequency. Also, we see the where is to be the transistor amplifiers are used. They are used in radio receivers, TV receivers, tape recorder, and other measuring instruments. Also, we know that there are the different types of the transistor amplifier, the linear transistor amplifier, non-linear transistor amplifier. In linear transistor amplifier, output will be directly proportional with the input or the dependent on the input. If the output is dependent on the input, that type of transistor amplifier is the linear. If the output is independent of the input, is dependent and independent of the input or the output is not directly proportional to input, that will be known as a non-linear amplifier. There are the different types or the different classification, different kinds of the transistor amplifier, that is based on the input, based on the input type, that is the voltage, the based on configuration, based on frequency, based on biasing, and number of the stages, that is single stage, two stage, three stage, or the multi stage. That is the based on the coupling. There are the different types of the coupling. That is direct coupling, that is the direct first stage is coupled with the second stage. Then RC coupling, resistor transistor RC coupling means the resistor and capacitor coupling, and the transformer coupling are these types of the transistor amplifier which are based on the type of the coupling. Okay, it means that there are the various types of the transistor amplifier, and these types are divided according to their cause, their function, their characteristic. It means according to inputs, according to voltage or the current, according to configuration, that is the common base, common collector, common emitter, that is according to biasing. There are the different types of the biasing, and the which biasing is used for the bias the transistor, that will be gives the type of the transistor amplifier. Again, the number of stages, single stage, double stage, third stage, multi-stage. Again, it will be depend upon the that is the direct coupling. There are the different types of the coupling in case of the transistor amplification. It means this chapter has huge utilization. Not only transistor amplifier, it is limited to transistor amplifier, types of the transistor amplifier with the different classification. Okay. Next, we are going to the transistor and what is the transistor biasing? That is the process of the biasing. Why the biasing is essential is to be studied in this slide. See here, what is transistor? We know that in transistor, one of the semiconductor material is placed between two opposite types of the region in adjacent to the opposite type. Consider that the transistor consists of the p-n junction formed by sandwiching. Transistor means two junction device, junction J1, junction J2. But how it is to be formed? By placing, by sandwiching one of the p or n type semiconductor, either p or either n is sandwiched between opposite type of semiconductor material. If p is taken, p sandwiched between opposite type of n, pair of n type semiconductor material मध्ये it will be placed in between the two n type semiconductor material. It is sandwiched, means p sandwiched between two n type semiconductor material, then npn transistor was formed. If, in other word, if n type semiconductor material is sandwiched between two p-type semiconductor material, then PNP semiconductor transistor, bipolar transistor is to be formed. See here, just I use the word that is the semiconductor device is the transistor. Transistor be also called as an bipolar transistor. Bipolar means there are two polarity are used, that is p-type having majority charge carrier holes. N type it having majority charge carrier, that is the electron. This both the means that inside the transistor current conduction can be takes place by the help of two polarity. Means that either holes as well as the electrons both are used to conduct the current through transistor. Means that in transistor current conduction can be takes place by using by the help of both the polarity with the help of hole as well as the electron. Hence it is known as an bipolar transistor. And why the bipolar? Because one semiconductor material is placed in between two opposite type semiconductor material, means n is placed between two p type or p is placed between two n type semiconductor material. Means that there are the two types of the transistor. One is the PNP transistor, another is the NPN transistor. We know that transistor is also called as a three terminal two junction device. Which are three terminal? That is emitter, base, collector. These are the three terminal. Emitter is taken from the emitter region, outer region. Collector is taken from the other outer range, outer end, and base is taken from the central region. Means that the transistor having two junction J1, J2, it having three terminal emitter, base, collector. It is two polar, means that is current conduction can be takes place by using the electron as well as the hole. What are the names? There are the different names of the transistor. Three terminal device, it is bipolar, BJT, bipolar bijunction device, bipolar, bijunction. There are the different names of the transistor. Do not go toward the name. Just go, just see what is the function, what is the characteristic, what is the basic characteristic, basic function of the transistor. In last lecture, we know that the basic function of transistor is to transfer the resistance from input circuit to output circuit. Means in transistor, the resistance can be transferred from emitter to base, junction to base to collector junction. This is the specific function, and due to this specific characteristic, that transistor can be acts as an amplifier. But when we know that transistor can act as an amplifier because it has a characteristic, basic characteristic of transferring the resistance from input to output. Yes, is it correct? But there is condition. Which condition? When transistor can able to act as an amplifier. In every condition, transistor can't act as an amplifier because there are the three stages, three working stages of the transistor. Transistor can work in three regions. Means in cutoff region, in active region, and in saturation region. The first region is cutoff region, output is off. Active region, output is on and it is according to input. And saturation region, that is output is infinite, high, not defining. All these three stages, working region, are applicable for the transistor amplification, for the process of the amplification? No. The cutoff region as well as the saturation region, both the down and topper region, are unuseful for in view of electronics. In view of electronics, cutoff region as well as the saturation region are unuseful, are not useful in view of electronics. In view of electronics, only active region is very effective. Active region is very applicable. And in active region, transistor acts as an amplifier. When transistor acts as an amplifier, if we switch, if we work the transistor in only active region, then it will be able to work as an amplifier. Means we know that if we want to use a transistor in its specific region with specific characteristic of amplification, then we have to switch, we have to work that transistor in active region. Then another question was arises, how one can switch the transistor, how one can work the transistor in active region. It cannot automatically work in active region. We have to do something. Then and then only that transistor can be work in active region. Unless we do something with the transistor, it cannot be worked as an amplifier or it cannot be switched in active region. See your friend, it means to work the transistor as the amplifier, we have to essentially switch that transistor into active region. And to switch the transistor in active region, we have to bias it properly. Bias. What is the Marathi meaning of the word bias? Arey, that fellow is biased with me. It means in Marathi त्याचा काहीतरी माझ्या बाबतीत पूर्वग्रह दूषित झालाय. Means that that person is biased. It means we have to bias the transistor properly, and if it is biased properly, then it will be worked in active region. Unless transistor can work in active region, we can't use as an amplifier. Means that to work transistor, to switch transistor, to operate transistor in active region, we have to bias it properly. And to bias it properly, it means there are the different methods for biasing the transistor. Means that transistor is biased by different method. Different methods are used to bias the transistor. Means to work the transistor in active region, means to work the transistor as the transistor amplifier. There are the different types of the biasing, and here we are going to know that is one of the master plan to bias the transistor. By which process? By which biasing method? Transistor is easily biased and it will be switched in active region. It will be operate in active region and it will be work as the amplifier. See here, transistor consists of two p-n junction formed by sandwiching either p-type or n-type semiconductor between pair of opposite type. Means n-type semiconductor material. See here, we are going to see the two types of the transistor. Here I am taking the laser. This is the one type of transistor. This is other type of transistor. One type of transistor is NPN transistor. P is sandwiched between two N-type semiconductor material, and three terminals are taken from each region. That is, this is N is emitter terminal, this N is collector terminal, and this P is the base terminal. That is emitter, collector, and base terminal, and this is the NPN transistor. PNP transistor, that is N-type semiconductor material is placed between two P-type semiconductor material and terminals are taken from each end. Then we get PNP transistor. This is the emitter, this is the base, and this is the collector terminal. PNP transistor. Okay. NPN, that is NPN transistor, is composed of the N-type semiconductor separated by thin section of P-type. There is the relation. Not only placing the material in between or not only sandwiching the material in between two opposite type, the transistor is formed. To design the transistor, there is some technique is used. What is that technique? These two are the thinner. That is says that is the N-type semiconductor material is separated by thin section of P-type. That is here in diagram it is also show that three regions with the equal width. That is this base region, this is emitter region, and this is collector region. And these are with the same thickness. No, for designing, the designer can take the care of the width of the transistor. Means that he can take the care of width. That is, that base is very small. The thickness of the base is very less. Thickness of the emitter is greater than base, and thickness of the collector is greater than emitter. Means that collector is larger in size than that of the emitter. Emitter is larger in size than that of the base, but lesser in size that of the collector. Collector पेक्षा कमी असते पण बेस पेक्षा जास्त असते. And the base is very less in comparing, say less size in comparing the collector and इमिटर सगळ्यापेक्षा सगळ्यात बारीक असतो तो बेस, त्याच्यापेक्षा मोठा इमिटर, त्याच्यापेक्षा मोठा कलेक्टर. दिस इज द रिलेशन इन थिकनेस, रिलेशन इन विड्थ at the time of the designing. Designing means the fabrication. At the time of the fabrication, at the time of the production of the transistor, the relation of the width is base is very less, greater than the base that there is the emitter, and greater than the emitter there is the collector. Okay, such a type of relation of the width is maintained at the time of fabrication of the transistor. Here also PNP transistor in which the P-type semiconductor material is placed, sorry, N-type semiconductor material is placed between two P-type semiconductor material. Then transistor terminals, we know that transistor is two junction, three terminal device. Transistor is semiconductor device. Transistor is bipolar, bijunction device. But what is the name of each terminal? The central is the base, one is the emitter, and one is the collector. Here transistor terminal, why they are named as, that is, this is here. Here the base is very smaller in width. The emitter is greater than the base, and collector is greater than this both base as well as the emitter. या सगळ्यांच्यापेक्षा मोठा आहे दिसतं बघा, इथं आपल्याला डायग्राम दाखवलेला आहे. याला इमिटर म्हटलं, याला बेस म्हटलं, आणि याला कलेक्टर म्हटलं. म्हणजे ही बेस टर्मिनल झाली, ही इमिटर टर्मिनल झाली, आणि ही कोणती टर्मिनल झाली मित्रांनो? कलेक्टर टर्मिनल झाली. मग इमिटरला इमिटर का म्हणायचं, बेसला बेस का म्हणायचं, आणि कलेक्टरला कलेक्टर का म्हणायचं? बिकॉज ऑफ द फंक्शन ऑफ दॅट रिजन. मीन्स दॅट these three terminals are nomenclatured by the function of that region. तो जो रिजन आहे, तो रिजन ज्या पद्धतीने ऍक्ट होतो, तो रिजन ज्या पद्धतीने वर्क होतो, अकॉर्डिंग टू वर्किंग, अकॉर्डिंग टू ऍक्टिंग, द nomenclature ऑफ दॅट टर्मिनल इज गिवन. नाव का दिले मित्रांनो? सगळं काही नावात असतं. विल्यम शेक्सपियर म्हणतो नावात काय आहे. इथं मात्र इलेक्ट्रॉनिक्स मध्ये सगळं नावात आहे मित्रांनो. त्याचं नाव त्याच्या कामानुसार पडतं. तो काय काम करतो, काय फंक्शन करतो, and according to that function, that terminal is nomenclatured. Here emitter section means that this section, just I can take the pen, here I can take the red pen. Here this is the emitter terminal, is the emitter terminal, just I am naming emitter. This is the base terminal, base is the base terminal, and is the collector terminal, is the collector terminal. See here, that is the section on one side is called as an emitter, एका बाजूला आहे, याला emitter म्हटलं. आता इथं p टाइप आहे मित्रांनो, म्हणजे इथं काय असणार सांगा? होल्स असणार मित्रांनो, इथं होल्स असणार मित्रांनो, इथं होल्स आहेत, इथं होल्स आहेत असे. इथं जर बघितलं तर इलेक्ट्रॉन्स आहेत, मेजॉरिटी चार्ज करियर. आणि पुन्हा इथं बघितलं मित्रांनो तर होल्स आहेत, होल्स. मित्रांनो 10 मिनिटानंतर आपण बाहेर पडू, पण लगेचच पुन्हा काय करायचं मित्रांनो, तुम्ही इमिजिएट जॉईन व्हायचं. जॉईन व्हायला एक 2-3 मिनिटं लागतील, मी पण लगेच जॉईन होईल. कारण आपण जो हॅक केला होता पासवर्ड, तो झूम न बंद केलेला आहे. आपल्याला नवीन हॅकिंग होईपर्यंत थोडासा आपण काळ वाट बघूया. तोपर्यंत आपण 40-40 मिनिटांना पुन्हा आतमध्ये जायचं आहे मित्रांनो, आणि आतमध्ये जाऊन पुन्हा काम करायचं आहे. मला मेसेज आलेला आहे, आफ्टर द मीटिंग विल बी एंड आफ्टर 10 मिनिट्स. आफ्टर 10 मिनिट्स मी बाहेर पडेन, तुम्ही बाहेर पडाल. इमिजिएट पुन्हा आपण काय करायचं, आतमध्ये यायचं आणि आपली मीटिंग सुरू करायची. ही सूचना तर मला काही दररोज द्यायची गरज नाही. तुमच्या लक्षात आलं, बाहेर पडलं की पुन्हा आत जायचं, बाहेर पडलं की आत जायचं. ओके ओके, नो डाऊट. सी हियर, दॅट इज इमिटर. This section is the emitter section. कुठे गेला पेन? ओके, दिस इज emitter section. आता emitter section मध्ये काय म्हणते बघा, this section one side has the emitter section and emitter is always forward bias with the respect of biasing. अरे biasing ची मेथड आहे ट्रान्झिस्टरला. जर आपल्याला ऍक्टिव्ह रिजन मध्ये अमृत जर आणायचं असेल, ऍक्टिव्ह रिजन मध्ये आणायचं असेल तरच तो ऍम्प्लिफायर म्हणून आपल्याला स्विच होईल, ऑपरेट होईल. पण त्याला बायास करावं लागतं आणि बायास करताना नेहमी एक मेथड आहे, एक लॉ आहे, एक मास्टर प्लॅन ठरलेला आहे. इनपुट सर्किट काय करायचं, फॉरवर्ड बायस करायचं, आउटपुट सर्किट रिव्हर्स बायस करायचं. इनपुट सर्किट फॉरवर्ड बायस करायचं म्हणजे कुठलं सर्किट फॉरवर्ड बायस करायचं, इमिटर बेस सर्किट फॉरवर्ड बायस करायचं आणि बेस आणि कलेक्टर सर्किट हे रिव्हर्स बायस करायचं. फॉरवर्ड बायस माहिती आहे तुम्हाला, डायोडला आपण फॉरवर्ड बायस केलं होतं. पी ला जर पॉझिटिव्ह जोडलं, पी टाईप सेमीकंडक्टरला जर पॉझिटिव्ह जोडलं, एन टाईप सेमीकंडक्टरला जर निगेटिव्ह जोडलं तर फॉरवर्ड बायसिंग. या उलट पी टाईप सेमीकंडक्टरला जर निगेटिव्ह जोडलं आणि एन टाईप सेमीकंडक्टरला जर पॉझिटिव्ह जोडलं तर that will be biasing, that type of biasing will be known as an reverse biasing. We are going that to bias the transistor means the one of the most essential method to bias the bias the transistor is that make input junction forward biased and output junction reverse biased with respect to CR, that is the emitter must be forward biased with respect to base. म्हणजे इमिटर P आहे आणि P हा P ला जोडलाय बघा, इथं बॅटरीच्या पॉझिटिव्ह टर्मिनल हे इथं P ला जोडलंय बघा आणि निगेटिव्ह टर्मिनल बॅटरीचं हे इथं कशाला जोडलंय बघा, बेसला जोडलंय म्हणजे N ला जोडलंय बघा. हे निगेटिव्ह टर्मिनल इथं N ला जोडलं म्हणजे बेसला जोडलंय बघा. म्हणजे इमिटर जर पॉझिटिव्हला जोडलं, इमिटर म्हणजे पी टाईप सेमीकंडक्टर जर पॉझिटिव्हला जोडलं आणि बेस म्हणजे एन टाईप सेमीकंडक्टर मटेरियल निगेटिव्हला जोडलं तर इनपुट सर्किट बायस होतं. अशा वेळेला अशा वेळेला या पी टाईप सेमीकंडक्टर मधले जे काही पॉझिटिव्ह आयन आहेत हे कुठे येतात बघा मित्रांनो, हे इथं फेच केले जातात. फेच केले जातात म्हणजे भरले जातात बॅटरी मधून एक्सटर्नली. बॅटरीच्या पॉझिटिव्ह टर्मिनल मधून जे होल्स येत आहेत ते होल्स एक्सटर्नली कशामध्ये फिल केलेत मित्रांनो, रिफिल केलेत. रिफिल पुन्हा पुन्हा भरले जाणं, रिफिल रिफिल रिफिल. म्हणजे इथं काय होतं, ही बॅटरी काय करते, ही बॅटरी मित्रांनो काय करते बघा, ही बॅटरी काय करते, हे पॉझिटिव्ह टर्मिनल पासून ह्या पी टाईप सेमीकंडक्टर मध्ये सारखे काय करते, होल फिल करते. म्हणजे मेजॉरिटी चार्ज करिअर इथला होल आहे आणि त्या होलची पुन्हा संख्या वाढते. म्हणजे लार्ज नंबर ऑफ मेजॉरिटी चार्ज करिअर तयार होतात आणि त्यामुळं काय होतं, हे जे आहेत ना, हे जे आहेत ते पलीकडे जातात. इथली संख्या वाढते, इथली संख्या होलची वाढल्यामुळं हे पलीकडे जातात आणि पलीकडच्या इलेक्ट्रॉन बरोबर त्यांचं काय होतं, न्यूट्रलायझेशन होतं. होलचा पॉझिटिव्ह चार्ज आणि इलेक्ट्रॉन म्हणजे बेस मधला जो काही मेजॉरिटी चार्ज करिअर आहे एन टाईप सेमीकंडक्टर मटेरियल मधला एन चार्ज म्हणजे इलेक्ट्रॉन, होल्स आणि इलेक्ट्रॉन एकमेकांमध्ये काय होतात, कंबाईन होतात आणि न्यूट्रलाइज होतात. न्यूट्रलाइज होतात. मग इथं हळूहळू हा पॉझिटिव्ह आहे, हा पॉझिटिव्ह चार्ज, इथला पॉझिटिव्ह चार्ज हे रिपेल होतात आणि हे कुणाकडे जातात मित्रांनो, बेस पासून इकडे कुणाकडे जायला सुरुवात करतात, ह्या कलेक्टरकडे जायला सुरुवात करतात. म्हणजे एमिटर हा एमिट करतो. एमिट करतो म्हणजे देतो. एमिटर काय करतो, चार्ज देतो, एमिट करतो. म्हणजे पॉझिटिव्ह चार्ज इथं देतो आणि तो कुणाकडे जातो सांगा, मधल्या इलेक्ट्रॉन बरोबर संयोजन होतं किंवा तिथं काय होतं, कंबाईन होतो, न्यूट्रलाइज होतो आणि पुढे कलेक्टर कडे जातो. म्हणजे त्याचं नाव काय, इमिटर. इट कॅन एमिट्स द चार्ज, इट कॅन गिव्स द चार्ज, इट कॅन एमिट लार्ज नंबर ऑफ होल्स, म्हणून त्याला इथे इमिटर असं म्हटलंय. लक्षात येतंय. जरा पलीकडची डायग्राम घ्या. हा आपण बघितलाय मित्रांनो. मी जरा खोड रबर घेतो, इरेजर घेतो आणि हे सगळं इरेज करतो फ्रेंड्स. जरा गंमत बघा, गंमत गंमत म्हणून मी इरेज केलंय, काही गरज नाहीये. आता पुन्हा ठेवतोय मित्रांनो आणि मला पेन घेतला. आपल्याला माहित आहे इथं होल्स आहेत मित्रांनो, मेजॉरिटी चार्ज करिअर्स, इथं इलेक्ट्रॉन आहेत मित्रांनो आणि इकडं आहेत ते पुन्हा होल्स आहेत, हे कळतंय तुम्हाला. आणि इनपुट जंक्शन याचं फॉरवर्ड बायस केलंय, आउटपुट जंक्शन रिव्हर्स बायस करणार आहे. मित्रांनो जरा बारकाईनं बघा, इनपुट जंक्शन हे फॉरवर्ड बायस केलंय बघा, मी इथं लिहिलंय बघा फॉरवर्ड बायस. म्हणजे या पॉझिटिव्हला पी दिलं निगेटिव्हला एन दिलं, फॉरवर्ड बायस झालं. आता मला आउटपुट जंक्शन म्हणजे कलेक्टर आणि कोण, कलेक्टर आणि बेस, मी काय केला बघा, रिव्हर्स बायस केला मित्रांनो. इथं लिहिलंय बघा रिव्हर्स बायस. रिव्हर्स बायस करताना या पॉझिटिव्हला एन दिले बघा, मी ह्या पॉझिटिव्हला एन दिलं आणि ह्या निगेटिव्हला पी दिलं. म्हणजे मी इथं काय केलं मित्रांनो सांगा, रिव्हर्स बायस केलं. ट्रान्झिस्टरला बायस करायचं. व्हॉट इज द बायसिंग? सहज तुम्ही इंटरव्ह्यूला गेला तर यू नो दी प्रोसेस ऑफ दी बायसिंग. लगेच आपण म्हणतो यस आय नो दी डिफरंट प्रोसेस ऑफ दी बायसिंग. मग तुम्हाला सहज म्हटलं जातं की अरे बायसिंगच्या प्रोसेस तुला माहित आहेत, तर हाऊ द प्रोसेस ऑफ द बायसिंग, बायसिंगची प्रोसेस कशी असते, तर by forward biasing the input junction and by reverse biasing the output junction, one can able to bias the transistor properly. And that process of the biasing, that process of the giving the voltage, external voltage, that process of the giving external voltage in one of the specific manner, that is the input junction is forward biased, output junction is reverse biased. That type of biasing is known as a transistor biasing. And unless you bias the transistor can't be work in active region. And if it is worked in active region, then it will be able to work as the amplifier. When it will be known as work as the amplifier, if it is properly biased. What is the biasing method? Input junction is forward biased and output junction is reverse biased. Then that transistor will be worked as the amplifier. Then biasing, what is biasing? Biasing, what is biasing? Make the input junction forward biased, output junction reverse bias. That transistor becomes biased properly and worked in active region to operate as the transistor amplifier. कसं बघा मित्रांनो, चेन आहे कशी बघा. तुम्ही प्रॉपर बायस केल्याशिवाय ऍक्टिव्ह रिजन मध्ये तो स्विच होत नाही. तो ऍक्टिव्ह रिजन मध्ये ऑपरेट झाल्याशिवाय तो ऍम्प्लिफायर होत नाही. मग बायसिंग करायचं म्हणजे काय करायचं, तर इनपुट जंक्शनला फॉरवर्ड बायस करायचं, आउटपुट जंक्शनला रिव्हर्स बायस करायचं. इथं मित्रांनो तसं केलंय. अगदी तसंच मी पलीकडच्या डायग्राम मध्ये दाखवतो. ह्या डायग्राम मध्ये बघा, प्रकार वेगळा घेतलेला आहे. एन पी एन टाईप ट्रान्झिस्टर आहे. एन मध्ये इथं मित्रांनो निगेटिव्ह चार्ज असणार, इलेक्ट्रॉन असणार. इथं बघा इकडे पॉझिटिव्ह चार्ज होता, इथं निगेटिव्ह चार्ज आहे. सेंटरला मित्रांनो इथं पॉझिटिव्ह चार्ज असणार, इथं पॉझिटिव्ह चार्ज आणि पुन्हा इकडे कलेक्टर मध्ये मित्रांनो निगेटिव्ह चार्ज. इथं सुद्धा काय करायचं, इनपुट जंक्शन फॉरवर्डच बायस करायचं. इथं केलेलं आहे मित्रांनो, जरा बघा बारकाईनं. आणि आउटपुट जंक्शन रिव्हर्स बायस करायचं. इथं एन ला फॉरवर्ड बायस करायचं म्हणजे एन ला एन द्यायचं, पी ला पी द्यायचं मित्रांनो. पी ला पी म्हणजे पॉझिटिव्ह टर्मिनल दिलेले आहे, फॉरवर्ड बायस केलं. इकडं सुद्धा एन ला पॉझिटिव्ह दिलं, एन ला पॉझिटिव्ह दिलं म्हणजे कलेक्टरला पॉझिटिव्ह टर्मिनल ऑफ बॅटरी जोडली आणि बेसला निगेटिव्ह टर्मिनल ऑफ बॅटरी जोडली. म्हणजे काय झालं, ओके. Friends, yes, Nikhil Patil, very nice. Within short time, within very short time, इमिजिएट काय व्हायचं, मस्त मस्त मस्त, व्हेरी नाईस व्हेरी नाईस व्हेरी नाईस. मित्रांनो तुम्ही सगळे हळूहळू ट्रेन व्हायला लागलाय. Just I am sending one of the message on a group. Join fast. Please join fast. मी परवा सांगितलं होतं लगेचच काय करायचं, एकमेकाला मेसेज करायचा. एखादा मित्र मैत्रीण विसरली असेल जॉईन व्हायला तर मेसेज करायचा. वी आर 15 पर्सन्स. जरा बघा अजून कोण झालं नाही जॉईन. ओके 16 झालो आपण. हा दीप्ती. ओके. Okay, I'm switching the sharing the screen again. Yes, Sakshi, you are able to see the screen. Sakshi?
Yes, sir.
Okay,
Oh,
okay.
sir, distinctly.
Very nice, very nice, very nice. Okay, I will start again. Here I will take on the pen. See here. This is second diagram. That is in this diagram, second diagram. The type of transistor was changed. That is the NPN transistor. And in NPN transistor, if the input junction same type for biasing, that is forward bias the input junction and reverse bias the output junction. Here we forward bias the input junction and reverse bias the output junction. This is N and this is the N. Means the fetching of the holes was occur. In NPN transistor, fetching of the holes was occur. And in PNP transistor, the fetching of the in PNP transistor, the fetching of the holes is occur. Here the electrons are fetched up. These electrons go toward the base section. There are the maturity charge carrier are the holes. They will combine with the hole. They neutralize and they goes toward the collector. As we know that here, that is the charge on battery is negative. Charge on the electron in n-type semiconductor is the negative. There is the repulsion and these are repelled from this end and they will be conducted toward the collector. Here also this n-type semiconductor material the plays the role of emission of electron. And here the emitter section plays the role of emission of holes. In PNP transistor, emitter emits the hole. At the same time, in NPN transistor, emitter section emits the electron. Hence, the name is given, that is the emitter. Why it is known as an emitter? Understand, friend? Because it emits the charge. In PNP transistor, emitter emits the hole. At the same time, NPN transistor emitter emits the electron. And hence, it is known as an emitter. Okay. Go to the next slide. Here also. The second is the collector. See here, this is the collector. We know that this is the collector. This is the collector. We know that in NPN transistor, this is the collector. We know that this is forward biasing. Forward biasing means this is the positive end, that is positive terminal, and this is the negative terminal. Here also the positive charge, there is the negative charge, and here the majority charge carrier are the holes. Means here hole, here electron, and here that is the hole. Here also the electron, here also the majority charge carrier hole, and here also the majority charge carrier electron. Okay. In collector section, the section on the other side which collect the charges called as the collector. That is the always reverse biased in PNP transistor, NPN transistor, in both the biasing method. That is the input junction is forward bias, output junction is reverse bias. Output junction has the collector, input junction has the emitter. Emitter is forward bias and collector is reverse biased. And due to the reverse biasing, this collector section acts as to collect. That is, emitter acts as emit and collector acts as the collector. Means it collect the charges which was emitted by emitter. That is, the charges which are emitted by the emitter is collected by the collector. See here, as I am discuss it in diagram first. See here, this diagram first. This is positive, this is positive, means the positive are repelled. They came in base section, they neutralize with the majority charge carrier electron. But we know that in here base, in this base, the majority charge carrier, that is जी काही इलेक्ट्रॉनची संख्या आहे ती फार कमी आहे, कारण तो सेक्शन आहे तो फार कमी आहे, त्याची विड्थ फार कमी आहे, त्यामुळे सेक्शन मध्ये इथे इलेक्ट्रॉनची संख्या कमी असेल. सगळेच्या सगळे इलेक्ट्रॉन काय होतील बघा, इथे न्यूट्रलाइज होतील. उरतील कोण? होल्स उरतील. आणि हे होल्स कुठे जातील मित्रांनो सांगा? या कलेक्टर सेक्शन मध्ये जातील. म्हणजे इमिटर मधले होल या कलेक्टर सेक्शन मध्ये काय केले मित्रांनो? आपण ओढून घेतले. इथं जरा बारकाईनं बघा मित्रांनो, इथं सगळे हा पॉझिटिव्ह चार्ज आहे आणि इथं जरा बघा मित्रांनो, इथं निगेटिव्ह चार्ज आहे, कारण हे रिव्हर्स बायस केलंय. कलेक्टर रिव्हर्स बायस आहे. रिव्हर्स बायस असल्यामुळे हा जो निगेटिव्ह चार्ज आहे या सगळ्या होल्सना इकडे कलेक्ट करतो आणि बॅटरीमध्ये न्यूट्रलाइज करतो. म्हणजे कलेक्टरचं काम करतो, तो कलेक्ट करतो. आणि हा जो आहे ना, हा जो इमिटर आहे तो इमिट करतो. इथं दोघांनाही वेगळी नावं आहेत मित्रांनो. इमिटरला डोनर असं म्हटलं जातं. डोनर म्हणजे देणारा. आणि इथं मात्र कलेक्टरला ऍक्सेप्टर असं म्हटलं जातं. म्हणजे कलेक्टर मीन्स ऍक्सेप्टर. इट विल बी ऍक्सेप्ट. म्हणजे हे जे काही चार्ज करिअर आहेत ना, पॉझिटिव्ह चार्ज करिअर विच आर emitted by the emitter, and some of the positive charge is neutralized inside the base, and the remaining positive charge and positive charges in the collector, all these are attracted toward the reverse passing polarity on the battery, and they will be collect, they will be accept all the positive charge, and hence due to this process the current conduction through the ट्रान्झिस्टर. या ट्रान्झिस्टर मधून काय झालं मित्रांनो? करंट कंडक्शन झालं. आणि करंट कंडक्शन झालं म्हणजेच ट्रान्झिस्टर इथं काय झालं? प्रॉपरली त्यानं करंट कंडक्शन केलं. करंट कंडक्शन केल्यामुळं हिअर वी नो दॅट लाईट गेलेली आहे मित्रांनो. बहुतेक आपण बंद पडू, आपण बाहेर जाऊ. जरा एक काम करा फ्रेंड्स, अटेंडन्स द्या अगोदर, आणि जितका वेळ चालेल तितका वेळ आपण चालवूया मीटिंग. हिअर that is the emitter base collector.